Okay, great. So welcome everybody. Thank you for coming on to this session on single sign-on specifically within a Zowe context. So hopefully today you're going to learn about what that looks like within Zowe, how it improves the user experience, how it makes Zowe more secure. You're going to hear about the mediation layer and some of the different authentication methods. I think we're going to take hopefully around 40 to 50 minutes to do the whole session. So there'll be some time at the end, hopefully, for questions. Yeah, if you do have any, then we'd be happy to answer those.
Yeah, if you have any during the session, feel free to
just also
raise your hand and ask.
Yeah, go ahead and interrupt. So let's just set the context a little bit in terms of single sign-on and what we mean by single sign-on, because we're going to talk about it within a Zowe context. As technologists, we all know what single sign-on is. We feel the advantages and benefits of it every day. For those of us who work for large organisations, certainly us at Broadcom, we have a company called Okta that we sign in with in the mornings, and then we have access to a whole range of applications that we use as part of our daily work. We don't have to sign into each one, right? So that so there's a very quick definition of single sign-on right there. When we talk about Zowe, I've grabbed this from the Zowe documentation to give you an idea of kind of what it means in a Zowe context. So it's you'll notice a few things there. We talk about a user authenticating, which generates an access token, which then means that the user can communicate with ZOS services that are managed by the API mediation layer. Okay, so there are obviously, again, benefits on the user side in terms of authenticating once, having access to multiple services into the mainframe, and then there's benefits on those folks, network security admins, those folks that actually manage and maintain that infrastructure, because they have that additional security that comes as part of this capability. We didn't introduce ourselves.
Yeah.
Should we do that now quickly? Go on, you go first.
Okay. So I'm Jakub Balhar. I'm a TSC chair. So if you are quite unhappy with Zowe in any way, please let me know. I promise that I will hear it out. I'm not promising I will do anything about it.
My name's Elliot, Jalley. I work a few desks away from Jakub in the Broadcom Prague R&D Center, and I'm product manager, and my focus is very much on Zowe, generally sort of open source for the mainframe, and yeah, I'm very, very happy to be here today. So, we've done introductions, we've done a little we've set the context around what we mean by single sign-on. Because the mediation layer is such a key part of this whole story, Jakub's just going to talk about the mediation layer just for a minute or two. We're going to assume that you guys basically know what it is, but we're just going to quickly give a quick definition of how that fits into this whole narrative.
So, some of you may have already seen this slide before when you were presented Zowe somewhere. In general, Zowe API Mediation Layer is a piece of infrastructure software that runs on the ZOS and that helps with the management of the APIs that are exposed from the mainframe, from the ZOS. The main target is the infrastructure APIs, regardless of whether it's infrastructure APIs provided by the vendors, such as the Broadcom ones, IBM ones, Racket ones, EMC ones, or the ones that are being created internally to serve and satisfy the needs of the engineers, developers, system programmers that are operating there. Where does API Mediation Layer helps is in bringing some sanity and in bringing some unification of certain overlapping concerns across all these services, like single sign-on, e.g. authentication. How do I make sure that as a user it's relatively painless to authenticate and use all the services regardless of whether they are coming from Broadcom, IBM, or our internal engineers. This is one of the layers and levels where API Mediation Layer helps. Another one is in making sure that the access to the mainframe is limited, meaning you don't have to open every service that you want to deploy on the mainframe. Instead, you open just the port for the API mediation layer, and then it handles the communication with the rest of the internal services. And then another important part that's linked to both of these concerns is scalability, high availability, and how do you manage all these overlapping concerns. Generally, the solution is you deploy Zowe or API mediation layer in HA mode, and then it handles the communication. It itself is HA, so if some of the instances go down, then they go down, it still will work. But it also helps work with the instances of the services, and as long as some of the services will be up, you will be able to leverage the functionality that they provide through the mediation layer without necessarily having to take care as the consumer of the fact that some of the services are down. So this is basically the role of the API mediation layer in the infrastructure. Apart from that, it provides some simple visualization that allows you to go and see what APIs are there in your infrastructure, what state they are in, do some try it out, help play with them a bit from browser before actually integrating them in your app. I think that's it for this slide.
Any questions at this point on the mediation layer? Okay, so as Jakub just said, the mediation layer acts as a kind of a security hub for all of Zowe, and it offers different flavors of single sign-on. There's different technology working in the background to ensure that single sign-on experience. So what we're going to do today is, we wanted to take you through those different flavors, and we wanted to kind of frame it around a typical day of hopefully not a typical day, because there's a lot happening in this day, but a day in the life of a system programmer. So we've invented this persona called Jenny. So she's a system programmer in a large organization. You could think of her as working in an infrastructure team, right? So she kind of maintains, manages the infrastructure that a business uses to run their organization, right? So her job is to automate, optimize as much as possible, keep things running smoothly. So that's Jenny, and we're going to take you through a number of different scenarios in her day, and then hopefully you'll learn about the technology that's working for her in the background. So first up, she's had her coffee, she's come in. First up, she wants to log in to the Zowe API catalog. Jakub had mentioned that earlier, just to kind of have a look at the different services, the REST services that are onboarded onto her mediation layer instance, and make sure that everything's up and running. And she does this by signing into her Okta account, which is mapped to her Mainframe account, and off she goes and is authenticated into the mediation layer and can see those services immediately.
So I will be talking about the more technical part of how it actually happens. Within the first around half of the presentation, we will be more focusing on what does the single sign-on look like and what are the different pieces from the client's or user's point of view. So it will be more about what you as a user can do and what authentication methods you can use in order to authenticate and how it looks like technically. So one of the important concepts that's underlying most of the modern authentication that you use in your mobile phones, in your company and everywhere is OpenID Connect. It's a specification that most of the authentication service somewhat conform to. And as we all know, somewhat is important part and most is important part, but it should help you. We did implement in the API mediation layer OIDC schema, which allows us to understand the OIDC token that we can get from these external providers and use the ESM functionality for external identity mapping to figure out whether for this specific token that we've validated with the external identity provider, there is actual user on the mainframe that the ESM knows of and believes that it's correct. So effectively what we are doing is we receive the OIDC, validate it, understand it, and if the ESM states with us, yes, it's correct, then we pass on some other authentication mean to the services that were onboarded. So effectively, that's the case for all of the methods that we will be talking about. We are acting as a relayer and transformer. So there are different methods that the users can use, and then there are different methods that the services can ask for. And neither of this side of the transaction needs to understand the other side. So the fact that the service behind actually wants JWT tokens doesn't matter for you. You authenticate with your OIDC, and if it's in browser, you probably don't even know. You just opened your Okta screen in our case every 30 minutes, because that's secure, obviously. And then this token will live in the browser, and the other service will be able to depend on it. I think we can move to the next slide. Yeah, this is just a bit about what it actually looks like. The OpenID Connect, on a more technical level, is still a JSON Web Token that's signed. So effectively, the OIDC provider provides us with this token. This token is living cookies or whatever you store it in your code. And then afterwards, and also if you need to understand more in the structure, you can look at different information about the specific person, how long it's valid, when it was issued, by whom it was issued, and other information. The information differs. There is a standard, nobody's actually doing it correctly. So it's a great standard. But it kind of works.
So just to finish on that, literally, if you have Azure, if you have Okta, if you have any of these identity providers that support OIDC, once you've logged in the morning to your network and you've opened up your email and calendar and you've done everything else, and then you need to go to the Zowe API catalog, you can do that, right? It's just another application which you can open without needing to re-authenticate. So I think that's the story here. That's what we're talking about. Okay, so this is, hang on, I haven't talked about this one yet. So that was Jenny logging in through Okta and having a look at the API catalog and viewing the services. Right. So a little bit later in her morning, she notices that a service has actually gone down. Now, Jenny is a keen user of VS Code. It's the IDE that she's comfortable with, understands, and enjoys using. And so, she needs to, in order to troubleshoot this service going down, she needs to, access system, get logs, and potentially have to restart any jobs that are hanging or what have you. And again, she's familiar with VS Code. She likes VS Code, and so she uses Zowe Explorer in VS Code to actually go and do all of that troubleshooting that she needs to do. And where single sign-on comes in here and the authentication piece is that Zowe Explorer is configured with a client certificate, and that's the authentication method between the extension into the mediation layer. Jakub.
So a bit about the certificates in general and the VS Code, and it works in certificates. First, VS Code does need API mediation layer in order for the client certificates to work properly. So if you want to use this functionality, you need to set it up. Second, it works from version 3. So for the VS Code, it's not possible to use the certificates properly in the versions before version 3. So these are the cases. The second part of it is that the certificates needs to be properly configured in the API mediation layer, which tends to be the problem that we are seeing across the organizations. Like, how do we actually work with the certificates, issue them, make sure that they are properly trusted. And in the order for API mediation layer to provide the proper authentication, there are two things that needs to happen. First, the certificate must be trusted, which means that somebody, usually system administrator, needs to add the root certificate and all the intermediate, so root certificate authority and all the intermediate certificate authorities into the trust store, keyring, whatever it is that you are using technologically on your ZOS, so that the API mediation layer says, yes, this is a certificate that I can live with and work with. If this doesn't happen, the communication stops before it even gets to the service actually, even to the API mediation layer service. It's happening on the layers below. So this is very important, and if you run into problems like your connection is rejected and you don't see anything in any logs, most probably there is some problem between the client certificate and the server certificate. And there are many things that could go wrong. The people that devised this whole schema for authentication and the certificates were insane. They were certifiably insanely clever as well, and they were really paranoid. It's necessary, but the result is that it's very difficult to do it right. So you will fail on the different algorithms that are changing over the time, and it will randomly break the functionality. You might fail, as I already stated, on the certificate authorities and the fact that if you don't provide the intermediate ones, it may or may not break depending on the clients. And then also the user needs to be authenticated and properly mapped in the ESM as to the external identity mapper. This is the second part of the thing. The first part is just that the server actually gets the information that there is a certificate. The second one is to figure out who is associated with this certificate. And within the ZOS, there is a concept of external identity. The ESMs, all of them supported. It's the same concept that is used for the OIDC. The same concept is used to map the certificate, specifically the public key of the certificate, to a specific user. There are actually two ways how to do it. Either you map the specific certificate public key to a specific user, or it's possible to create some rules that limit who exactly and how can access specific keys. It's a bit more complex and I wouldn't go into it in this session. In general, you can see here how it looks like. So if you are trying to authenticate, you will have some PEM and private key certificate and the private key for it. You will provide it in your VS Code JSON configuration profile, and then it should ask the password when you are trying to use it, if there is one specified, and afterwards all the following network calls will be used with this, or will use this certificate for the specific profile. In this case, it's going to be ZOSMF calls that will go through the API mediation layer that will transform it to something else for the ZOSMF. So, any questions to all this certificate beauty? Maybe one more, it's also usable, yeah, we will get to it. I don't know if we will get to it. It's also usable for other cases than just the VS Code. Another very common use case is where you need to store somewhere some kind of credentials, but for the regulatory reasons you can't store the username and password. So instead you use the private key of the certificate within the pipelines or something to do the authentication. Technically speaking, I feel that it's more or less the same, but the regulators believe that it's a different, so you can use one, you can't use the other. And I think that's it for this one. Any questions around it?
Okay. Yeah, I have a quick question, but it can wait till later, we can talk about it afterwards. I was working with a customer last week and they had an issue which is where the certificate that they got issued was from a corporate portal, and they put it straight into the credential manager, the Windows certificate manager, and they flagged it with a special flag that said no export. So they didn't want to see that certificate private key lying down on disk, which is what I just wanted to throw that up. I didn't want to sort of like a firework, but that'd be something that'd be interesting. It feels like when version 1 had user ID and password in the clear, it feels like we're sort of kind of repeating history a little bit. It'd be interesting to see if there was a way to.
There is, it's not been implemented yet.
Okay, but all right.
At least as far as I know. So.
But that would be. But we're not pulling that out. Okay.
I think that right now there is.
It's just an evolution of that.
I think that there is an evolution needed for this as well. I think that right now you can't really store it in the secure store. You need, technically speaking, you store it on the disk in the password protected store. That's theoretically secure, but for some reason different people feel that different stores are differently secure in this case.
Right, there's
the PEM format is itself also secured. So it's secured by the password that you need to provide. So technically speaking, it's also secured, but this is rather.
Okay, thanks, Jakub.
Sorry. Okay, so let's move on.
Right, so back to Jenny. So she has some dashboards that she has set up in the past to monitor the performance of her DB2 instances. And the dashboards are in Grafana with Prometheus, and it's consuming a sysview REST API to to actually gather that data and that is what's pushing the data into the dashboards. So this is all performance data that she's getting. So she's opened up her dashboards and she can see, you know, there's some red in the dashboards, and so there seems to be, you know, a performance issue with a specific and important DB2 instance. Jakub, what's going on here then behind the scenes?
Well, behind the scenes, one of the use cases that we see quite often that uses these client certificates is that there are other third-party tools that are running quite often off ZOS that needs to get some data from the mainframe. Most of the cases that we are talking about and what we are seeing, we are talking about metadata and telemetry. We don't necessarily see the customers putting the customer data out of the ZOS, but we do see a lot of the telemetry data being thrown away from the platform to analyze, process, and do something about it. And one of the tools that's used quite often is Grafana. And within the Grafana, when you are specifying the data source, you can specify that the authentication for the data source is the client certificate, which is basically what we are doing here. The services that are providing the data it themselves doesn't really provide certificate authentication, so the API mediation layer manages the layer between the API mediation layer and the actual service. But from the external point of view, you live within a world where there are certificates, provide a certificate, and API mediation layer does something about it to make sure that you get the data you need, basically. It simplifies the setup, and again, the main point here is to get rid of the username and password, and also not always the username and password is an accessible method of authentication for all the endpoints, while the certificates are. So the typical use case is that when you have username and password, you log in and get some other means that you live with, actually, regardless of whether it's cookie or whether it's JWT token that you get directly in response or whatever else. This is a typical use case. For the client certificate authentication, the difference is that usually you actually always provide a client certificate with every call and use it as the mean of authentication that's then translated and validated on every call, which makes it easier for the tools like Grafana to, instead of having to understand the flow, always just provide a certificate. So that's the simplification here.
Yeah, we see this quite a lot. That, you know, in the past, before this was available, or before there were kind of proven use cases where folks were using certificates in these cases, you know, there were organizations out there that were, you know, not happy on kind of exposing password and usernames out there, and so, you know, this certificate really does solve that problem. Okay. So we talked about previously how that Jenny was seeing some performance issues related to this particular DB2 instance. She could see that in her dashboards, and now she's working with that dev team to have another look at the changes they've made, which are impacting on performance, and she's working with them to prepare a Jenkins pipeline. And you're going to see now with Jakub how this Jenkins pipeline is actually using personal access tokens, which is another authentication method we haven't talked about yet, that has some very interesting and specific capabilities.
So first, for those of you that use like GitHub, I think that most of you have seen GitHub at least by now. The GitHub uses the concept of personal access tokens. It's a token that are scoped for the specific operations. They are limited, but on the other hand, they can live quite long. Usually the recommendation is 30 to 90 days, but technically speaking, they still support even unlimited validity. Personal access tokens is the same concept and functionality implemented in the API mediation layer. So when you log in, you provide either your username, password, or you provide the client certificate, whatever you want. And you can, instead of this traditional JWT token, get the personal access tokens. It's type of the JWT tokens which contains information about the scope it is valid for. it's signed, so you can't change the content. Like you can take a look at what this specific token is valid for, but you can't change it. And therefore, it's a very good candidate for the pipelines, because the pipelines usually tend to interact with 1, 2, 3 services, but not with everything. Unlike when you create a client certificate, it usually tends to be, well, it depends. You can create a certificate user that's service, and then you have a client certificate for every service that's specific, but it's a lot of management. Typical case is that there is some service user that has authority over lots of services, and the client certificate is not limiting it any further. So you can access all of these services. The personal access token instead is created, basically for every pipeline you create the personal access token that you care for, give it the validity that you want, regardless of whether it's 30 days, 90 days, or 1 year, depending on configurations. And you say, okay, for this pipeline, I want you to be able to access only SysU for DB2 and only IMS, nothing else. And so if you try to use this token, for example, because somebody stole it for any other service, nothing will happen, it will just reject it. So it limits the scope of the potential problems and risks if the token is stolen. So this is basically it. It's again JWT token, so technically speaking you can take a look at the contents, and the API Mediation Layer provides some management functionality about it, like for example if you suspect that there is a breach, you can revoke all of the tokens for specific service, or all of the tokens for specific user. So you can figure out what are the potential risks and potential scope of the breach you see, and based on it, you can impact just the part of the organization where you believe it's happening.
Yeah, one quick question. So I'm very used to all of that hex, you see it flying around. When you had the view on the right in the previous chart, which was the sort of expanded JSON, what tool did you use? When you say you can look at it, is that, I know you can use key tool and other
I think that for this is the JSON web tokens.io. Like there are plenty of web services that will transfer this to you. I think there's VS Code extension that also allow you to inspect the content.
So you can just feed in all of that Gobi hex and it shows it in a pretty
Yeah.
Okay.
It's easier to do there. Like technically speaking, there are also the command line tools, but like I don't know of anyone actually using them.
Okay.
So I'm not gonna recommend them. But there are websites, or if you are not able to use websites, there are extensions for VS Code that you can download and that allows you to inspect the tokens.
Okay.
Yeah, this is just an example. You can use the path for the access to the IBM Zowe SMF in this specific case, and then you can get some information about, in this case, specific job. So this is just an example of how it actually looks like with Coral. It theoretically should work for you, so once you grab the slides, you can even try it afterwards.
Okay, so Jenny made it to lunch. It's been a hard day. She's a bit spaced out after having to work on all these different issues, but she's enjoying her sandwich. And we move into the second half of the day. So she gets back from lunch, and again, she discovers that an API is down. On this occasion, it's a slightly more complex issue because it's going to require her to troubleshoot across sysplex and potentially across security domains. So in order to do this, she enlists the help of an operations support engineer, and together they begin to troubleshoot the issue.
So first, this is still evolving as we are learning more about how exactly these use cases looks like. It's been with Zowe for 1.5 years by now, but we are still finding out more about how exactly the life of the people managing those cross-sysplex, multi-tenant or multi-sysplex environments look like. Our current support and understanding is built on top of a few things. We've already talked about the OIDC. This is the external identity mapper that we use to provide the link between different identities in different security databases and the actual external identity. So this helps with the part I log in with my Okta credentials, and then the API mediation layer and the routing and the translation of the credentials can handle the fact that for different calls, it's the actually different user doing the work. Because the main problem is within the different TSMs there are going to be different users. Just the fact that the user has the same name doesn't necessarily mean that it's the same user. And on the other hand, there may be some sysplexes where, despite the fact that there is a user, it's named differently. So the external identity mapper, external identity is what links all these concepts together. And we decided to use the OIDC as the primary, but technically speaking, it would work with the client certificates as well. It's the same concept. The mapping is the same, it's just the different commands in the RACF, TSS, and ACF2. And apart from that, another problem that's associated with this is the routing. So what services are available and where they are, where do they actually live in this infrastructure. And on this top and on this concept, we built the idea of like the central gateway. So there is a gateway that's upfront all the systems that contains some kind of discovery service where you can get the information about all the LPARs that are involved and the services that are available of the LPARs. And you can use it to route to any of the systems, tenants, sysplexes that are available, and then to a specific service on this subsystem or this sysplex basically usually. So that's why we are bringing it here. First of all, if you have this use case, we are interested to hear more and to work with you on making sure that it's really comfortable. Like it works now, but we are still finding what comfortable looks like. That's the part that's ahead of us. Yeah, I believe that I basically covered it.
But if you imagine the support engineer that we had before and Jenny, so you imagine them troubleshooting this and they're going across to these different sysplex, right? Different security domains. You know, in theory, what this allows them to do is to do that without having to authenticate each and every time, right? That's the beauty of it, so that they can actually get to the cause of the issue much faster. It's a more comfortable experience
And also get the information on what services are still up.
Yeah.
Because when this is happening, there are some of the services, some of the instances may be already down on the sysplexes. You should be able to get this information from the service registry, from the central one. You should be able to see, okay, on this sysplex, I have only one sysview instance left, or I don't have any at all, so I will need to find another way how to access it.
Yeah. So I think you can imagine this being used in an operations context. I think that's kind of the where we're seeing it at the moment. Right. So that was a tough one, but she got through it and got that API back up and running and pretty quickly thanks to that single sign-on capability across Sysplex. So now she's got a few bits and pieces that she's got on her task list that she can finally get to. She has a few internal teams that are asking for some support to onboard, integrate, and secure their APIs on the API mediation layer. So we're going to take you through 3 different examples here. I think we have three different authentication methods. So the first one here is a team is asking about certificate forwarding.
So this is the second part that I was talking about in the beginning, and that's what the API mediation layer does to provide information about and authenticate towards the services that are behind it. First thing that we provide is the implementation of certificate forwarding. That means that if you authenticate with a certificate and you reach the TLS ending proxy, which means that the proxy is happening on the layer 7 of the TCP/IP protocol, which API mediation layer is, there is still a way to pass this information in the standard way on the subsequent services. And it's outlined in the RFC 6440. You can go and read it, but I don't recommend it, it's boring and really long. But the main part is that basically you build the trust between the service, API mediation layer, and the service on the other side, and then you provide the information in the client-side headers. So there are headers, client-side and client-side chain, where you provide the key information that the subsequent service needs to validate anything they need about the certificate, basically. Yeah, that's it for this one.
Okay, so that was certificate forwarding, and then the next item on our task list was a team that wants to use a JSON web token as the authentication method for their particular service they want to onboard.
Yeah, so basically, when you will use this is if you have a services that you want to integrate in the API mediation layer. Like as a user client side trying to authenticate, you don't care. This doesn't matter for you at all. But if you have some services that you want to onboard into the mediation layer and make them accessible through the means we've been talking about for the first 35 minutes, then this is how you integrate. The certificate forwarding is relatively straightforward. Quite often it's supported by default by the libraries that you are using to build the services. Another one is JWT tokens. API mediation layer either forwards the tokens that are created by Zowe SMF based on how exactly the API mediation layer is configured, or it can issue their own services, issue their own JWT tokens, sign them and provide them for the services with the API that these services can ask to validate or query more information about the tokens. So it's relatively easy. We also provide Java library, so if you have Java services, there's a Java library that has the API covered, where you can just call the Java methods and it does these calls through the rest in the background without you having to care about it. It's just a simplification, it's not changing anything much. But if you use it, it's very simple to configure. Like some of the other methods, specifically the last one we will be talking about, there is no more configuration. You just onboard the service, and once it's onboarded, it's there and it will work. You will see there is a difference later.
So we've talked about certificate forwarding, JWT, and now the third of the three task items that Jenny has is a third team that wants to use pass tickets. And the reason that they've given to Jenny is that with certificates there can be a little bit of overhead to manage those certificates, expiration and so on and so forth, and so they want to avoid that, and they're looking to use pass tickets instead.
Yeah, it also may have been a vendor's team that believes that it's easier for them and they won't have to do the implementation work. The sad part is that it usually entails some amount of configuration on the client side. So like if you deploy a service that you want to onboard to the API mediation layer where the pass tickets are going to actually be used, you need to configure first pass ticket setup in general on the ZOS system, and then the setup for the API mediation layer to be able to generate the pass tickets, and then for the API mediation layer to be able to generate the pass ticket for the specific service that you are onboarding. And all these three things may not happen, and it shows different errors that are sometimes a bit harder to debug. But it's doable, it's just that it makes it very easy to integrate the services. Like if your service already accepts authentication in the username password, then it's gonna just work for you. But the configuration needs to happen. It's just that the configuration is moving elsewhere. From the implementation in the JWT and the client certificate chains, it's moving to the actual configuration on the ZOS system. Each of it has its own benefits and drawbacks. And I think that's it.
Yeah, so she completed the last of her three tasks, and so that's the end of Jenny's day.
Yeah, it's like 8 p.m. based on what we've covered.
Yeah, at least. Yes.
Yeah, that's it. We are here in the Open Mainframe track, so if it's the second track, so there's a chance you haven't seen it 10 times by now. And if you want to know more about the Open Mainframe projects that you can leverage in your daily work, it's not just Zowe, it's others. They are here, and there is a QR code. And we don't care about security, so please go there and use the QR code. Don't be scared, it's just from random strangers you've never seen before.
There's another QR code here.
Yes, another one. So this is about where you can find us. So if you want to connect with us outside of this conference, it's possible to either follow the Open Mainframe project on various channels, or there is a Slack for the Open Mainframe project where most of us that you can see around here from Zowe are active. There are channels where we are trying our best to help you and definitely talk about things and announce things that are happening. So that's about it.
Yeah, please do come and interact with us if you're not doing that already. It's great to hear about your experiences, what's missing, like what's working well for you. You know, we constantly seeking that feedback, and it really helps us, you know, set the direction for the whole project. So please do connect with us if you haven't already.
As a Zowe, we have quarterly calls where we present what we've done in the last quarter and what we did there for the release and what are our plans for the next release. And this is the point where you can actually go and say, hey, but I really believe you should be doing something different, and we do tend to listen. Yes, this is the great conference release. I guarantee you that you will see this many times in the next coming days, and I have no idea what it's about.
Good, and yeah, please do give us some feedback so that we know, you know, whether this was useful, if we pitched it at the right level for you, you know, that kind of thing. It really helps us. You know, we go to many conferences, and so it really helps us to kind of, you know, properly refine the presentations that we give. So please, if you have a minute, please do give us some feedback. And I think we said between 40 and 50 minutes, didn't we? And so we have time for questions if there are any at all.
Questions, comments, complaints.
Okay, so very basic question, I think. So I have some services defined on the mainframe, and they are exposed as REST APIs. Now, if they want to be enabled, if I want them to be enabled with SSO, you're saying that they should be connected to the Zowe API Mediation Layer, and the API Mediation Layer in turn will support different SSO mechanism.
Yes.
Okta or whatever
Yeah.
I want to use.
Exactly. So then maybe question from us, are you using Zowe? So it's not like, yeah. And are you using Zowe on the server side? Like, have you worked with either virtual desktop or the mediation layer already by now? Is there? No. So this is still something, so if you don't know, there is an installation and configuration talk in a few days from me. It's
Thursday.
Thursday, yeah.
Thursday afternoon.
Oh, I guess nobody's gonna be here, but if at any point it's possible that you are still here, it's Thursday afternoon. We'll be talking about how to install and configure this part.
Okay, well, thank you very much for coming along. Appreciate it.